Hi everyone, welcome to my channel again. This is Alistair Apollo alias Emma Watson at your service. Welcome to once again, welcome to my Math is Fun channel. So how are you today? How's everybody? I hope everybody's doing good, great, and awesome. So before anything else, let me shout out once again uh, my students in SSP or STE program, Group 1 and Group 2 in the school year 2020 to 2021. This channel is for you, especially if you want to learn more about mathematics. So that is so excited. So another thing, I would like to shout out my friends there out there who are still subscribing. Ma'am Gonzalez, Ma'am Dehega, Ma'am Holy Jade, Ma'am Doug Pin, and also Sir Dexter. Hello, everyone. Thank you for subscribing my channel, and I hope everybody is doing um, or learning something in this video discussion. So another thing also, I would like to shout out Mr. Swender who always supports and watch the video in my channel. So hi, thank you so much. And the section Bigonia, Lilac, Gladiola, and Magnolia, thank you so much for subscribing my channel, and also for Granada, Marang, Manzanas, and Atis, Azucena, Sampaguita, Sunflower, Manga, Waling, Waling. Of course, I forgot the Waling, Waling. Hello there, Waling, Waling students, and also the seven tulip. So please, those who are not yet subscribing my channel, kindly subscribe it. Don't worry, your time will not be wasted because you will learn something, a lot of things. Everything will be changed about mathematics in your mind. You thought before that math is difficult, then after watching the video, you will realize that math is easy, fun, and very interesting. Let's just enjoy and having fun learning new things in mathematics because math is fun. The essence of mathematics is to make simple, it does not make simple things complicated, but to make complicated things simple. So are you now all ready? I am also ready. Okay, so let's start with our discussion um, in this video discussion. So I hope everybody will participate and will finish watching the video. We'll start. I will. I mean, will finish watching the video. See you at the end part of this video. So for today's lesson, we're going to uh, discuss about some important applications of the laws of exponents in simplifying. But before anything else, I would like to remind everybody to please subscribe my channel and then click the yellow bell button so that you will be notified once another video will be uploaded in my channel. And aside from that, you can also share my link, my video, or this channel that you are watching, that you are in rather, to your friends, especially those who are struggling mathematics, in mathematics rather, and those who want to really improve their performance in all subjects in math. So I am here with you to help you understand everything that you want to learn in math. So are you ready? Yes, I am now ready. It's very important for us to really know the importance of the laws of exponents. We have the product rule, the power of a power rule. We have the quotient rule. We also have the product of a power rule and a power of a product rule rather. And also we have the negative exponents and the zero exponents rule in our previous videos about the zero and negative exponents as well as in the integral exponents. So this time in this video, we are going to apply those concepts that we have. Though we applied it already, but we are going to maximize the use of the laws of exponents, including the zero and negative exponents rule in simplifying algebraic expressions. So important examples that we have to remember in this video, that negative 3 to the power of 4 means, again, it means negative. Take note of this. These are common errors in the laws of exponents. It means 3 has only the exponent of 4. Negative is not included. That's why negative 3 to the power of 4 means negative parenthesis 3 times 3 times 3 times 3, which gives you 81. Then multiply it by negative, that gives you negative 81. Okay? So I hope you will be able to remember that one. That is a very important skill in exponents. Another thing that I want you to remember, this one. So this means a quantity negative 3 close quantity to the power of 4. That means negative 3 repeats 4 times. So negative 3, negative 3, negative 3, negative 3 being multiplied by itself. That gives you positive 81. So now here's my questions. What's the difference between the two? The solution or the answer will give you the difference. Okay? So when we say negative 3 to the power of 4, since it doesn't have a parenthesis, that means only 3 has a power of 4. Unlike in here, this one, there is a parenthesis. As you can see, there is a parenthesis. That's why including the negative is raised to the power of 4. That's why it becomes positive 81. So I want you to remember that one. Another thing also that I want you to remember in this topic is the negative 3 to the power of 3 means, again, negative 3, negative times the quantity of 3 times 3 times 3. That gives you negative 27. Can you follow? So easy, right? So same thing also in here, negative 3, since it has parentheses, that gives you um, negative 3 times negative 3 times negative 3, that gives you negative 27. So I want you to remember, I want you to observe the exponent. I mean, I want you to compare this one, the two given. Negative 3 raised to a quantity, negative 3, close quantity raised to the power of 4, and quantity, negative 3, close quantity raised to the power of 3 or cube. What have you observed? What have you noticed? Look at their final answer. Hmm. What do you think? What have you observed? I want you to observe something. When a negative base, again, when a negative base is inside in a parenthesis, as you can see on the screen, when it is raised to an even number, the result will be positive. Okay, it's always, sir. Yes, it's always. When the exponent is even and then the base is negative and it is enclosed in a parenthesis, then the result will be positive. Unlike in here, this one below, the one that I checked, this one, in here, observe, the base is negative and it is enclosed in a parenthesis or inside in a parenthesis rather, and then raised to the power of cube or cube rather. So cube is an odd number and it's negative. The base is negative rather. So what happened to the final answer? That becomes negative 27. So remember the even and odd exponents. If it is even, that becomes positive. If it is odd, that becomes negative. I am referring to the base, which is inside in a parenthesis, and the base is negative or having a negative sign. So you can apply only to that situation. Okay? So I hope you'll be able to get something in here. Another thing also for the variable expressions. When we say x to the power of 5, that means when we use parentheses for multiplication, that is equal to x times x times x, as you can see in here. This one. X to the power of 5 can be written in this form. This is what we call, again, in our previous topic, a long notation. This is an exponential notation. So y cubed means y times y times y times y, 3 times multiplied by itself. So that's for the variable expression. Now, let's go over with the substitution and evaluating. So in substitution and evaluating, there are steps that we can follow. The first step, write out the original problem. Write out the original problem. That's the first step. The second step is show the substitution with parentheses. Again, show the substitution with parentheses. Next, next is work out the problem. An example, let's apply the steps. Again, what's the first step? Write out the original problem. The second step is show the substitution with parentheses. And third, work out the problem. These are the steps in substitution and evaluating algebraic expressions. Have to, um, let's try to solve the example. The example in here is x is equal to 4. That is an equation, not an expression, right? When we have x is equal to 4, what will happen, class? When we have, sorry, okay. When we have x is equal to 4, then solve if x is equal to 4 when the expression given is x cubed. So how will we substitute? Again, in the given, we have the expression given x cubed and x is equal to 4. What will we do in substitution in evaluation? When we evaluate this problem, what will we do? Since the value of your x is equal to 4, you will just replace x as 4. Okay? So let's see what will happen. That's the first step. See? We replace x as 4 since x is equal to 4. Oh, see? Your x here in the given expression becomes now, it becomes 4 since x is equal to 4. That's step number 2 or following the step number 2. What about for step number 3? Of course, we will work out the problem. So 4 cubed means 4 times 4 times 4, and that gives us 64. That gives us our answer, 64. Sorry. So that gives us an answer of 64. So easy, right? Yes, it's very easy to substitute and evaluate algebraic expressions. Another thing that we're going to that we are going to evaluate in this example, another example. So in our example, sorry, why is it? It's hanging. Okay, our example is evaluate the variable expression when x is equal to 1, y is equal to 2, and w is equal to -3. In the given expressions, this is the expression given. Again, do not forget your x is 1, your y is 2, and y is -3. So let's now start. The expression is x squared plus y squared, quantity. So step 1, of course, just rewrite the expressions given. Next is we will substitute as what I've said. X is equal to 1, so replace 1 to your x. That's why it's 1 squared or quantity 1 close quantity squared. And y is 2, as you can see on the screen, 2. So 2 squared. So that gives you 1 squared is 1, 2 squared is 4. So 1 plus 4 is equal to 5. That's the final answer. So that's how you do it. So this one, the answer is 5. So again, do not forget your x is 1, your y is 2, and your w is -3. So the expression now given in example number 2 is what? This one, this expression. So step 1, rewrite the expression. What's the step number 2? We substitute the value to evaluate. Your x is 1, your y is 2. So 1 plus 2 is 3. Then that gives you step number 3, which is 3 close quantity squared. Then 3 squared means 9. 3 times 3 is 9, not 3 times 2. Sometimes others will answer 6. No, that's not 6. 3 squared means 3 times 3. Okay, another example or expression, wx raised to y. Step 1, rewrite it. Step 2, substitute. Your x is, your w is -3 as based on the given. Look at the given above. Your w is 3. And then, -3 rather. And your y, and your x rather is 1. And your y is 2. See the given, this one. We just substitute it here. Okay, substitute mean we will just replace the variable into a numerical value, which is given on the problem. So that gives us -3 times 1. 1 squared is 1. So -3 times 1, that gives you -3. That's step number 3. Okay, so easy, right? All you have to do is just to replace when you substitute. And what I mean is when you evaluate algebraic expressions, you can use substitution. You can replace, when we say substitution, that means we replace the given value. What I mean, we will replace the variable into a given value depending on the given. That's why I said given value. So now let's proceed to the next. Multiplication properties. These are just recalls. Product of powers. Again, the property is used to combine two or more exponential expressions with the same base. It's like this. 2 cubed times 2 to the power of 5. That gives us 2 times 2 times 2 for 2 cubed times 2 times 2 times 2 times 2 times 2 for 2 to the power of 5, as you can see in the arrow. That gives us, copy the base 2 and then add the exponent 3 plus 5, and that gives us 2 to the power of 8. Can you follow? Also exciting, right? Which can still be simplified into 256. How? Just multiply 2 by itself 8 times. That gives you 256. Next, x cubed times x to the power of 4. You have it x times x for x cubed, and 4x for the x to the power of 4. Then applying the product of powers, this is just a sort of review. Then copy the x and then add the exponent 3 plus 4. That gives us x to the power of 7. So that's the application of the product of powers. Okay, that we just discussed in the laws of exponents under the integral exponents. So under also in the multiplication properties is the power of a power rule. So again, as a reminder or a recap rather, this property is used to write an exponential expression as a single power of the base. Again, this property is used to write an exponential expression as a single power of the base. So I want you to change the word "and" there as an exponential expression. So we have it here as an application. When we have 5 squared raised to another cube, that gives us, there are 3 5 squared, correct? As you can see in the picture, that gives us 6. That's why we multiply their exponents as 2 times 3, which is equal to 6. That's why we have 5 to the power of 6. And if we simplify it, that gives us, it's up to you. You can solve it on your seats. Another x squared to the power of 4. There are 4x squared. So that gives us x to the power of 8. So that's the power to a power rule in the laws of exponents or under multiplication properties. Another basic concept under multiplication properties is the power of a product rule. According to this rule, again, if you could still remember, this property combines the first two multiplication properties to simply exponential expressions. Example, -6 times 5, and then quantity squared, close quantity squared. That gives us -6 close quantity squared times 5 squared, which is equal to 36 times 25, which gives us a simplest form or an answer of 900. Another example that we have there on the screen, 5xy closed quantity cube. We distribute 3 to 5, to x, and to y. So we have it 5 cubed, x cubed, and y cubed. That gives us 5 cubed means 5 times 5 times 5, which is 125, and then x cubed, y cubed. So let's have another example. This one, 4x squared times closed quantity cube times x to the power of 5. Using the power of a product rule, we can have it distribute 3 in the parentheses, inside the parentheses. So we have it 4 cubed times x squared quantity cube times x to the power of 5. Then we have it 4 cubed is 64. Then x squared raised to cube means x squared times x squared times x squared. Can you follow? I hope you can follow. Times x to the power of 5. That gives you 64x to the power of 6 times x to the power of 5. In this case, we will apply I want you to look at the arrow, the x to the power of 6 in there, and x to the power of 5 can be applied, or we can apply the product of a power property or power of a product rule. So we will just copy the base and add the exponent. What is the result, do you think? Yes, it's 64x to the power of 11. Just copy the base, rather, x, and then add the exponent. 6 plus 5 is 11. So we have it 64x to the power of 11. So I hope you can follow. So in summary, product of powers, just copy the base and add exponents. Power to a power means you copy the base and multiply their exponents, as you can see in the picture. Another thing also, class, is the power of a product, wherein you distribute the exponent, just like the property in there, the symbol or notation that we used. And now we will review about the zero and negative exponents rule. According to this rule, anything to the zero power is 1, or any number or expressions that is raised to the power of 0, the answer is 1. Just like in here, the examples, 3 cubed, 27, 3 squared is 9, 3 to the power of 1 is equal to 3. What is the example in here? So the 3 to the power of 0 is equal to 1. Another thing also are the negative exponents rule, as you can see. Okay, for a while. So if we have, okay, 3 cubed is 27, 3 squared is 9, 3 to the power of 1 is 3, 0 exponent, the answer is 1. Negative exponent, of course, you're going to get its reciprocal, 1/3. 3 to the power of negative 2, 0 exponent rule. That's why 1 over 3 squared. And then 3 squared is 9, so 1 over 9. And for 3 to the power of negative 3, 0 exponent rule. Again, reciprocal of 3 to the power of negative 3 is 1 over 3 cubed. Again, why do we use, or why do we get its reciprocal? Because negative exponent is not accepted. That's why to make its exponent positive, then we have to get its reciprocal. So always remember that one. If you want to simplify it, that gives you 1 over 27. 3 cubed means 3 times 3 times 3. Okay, let's do this one. 2x to the power of negative 2, that gives you, okay, only x has a negative exponent. So get its reciprocal, then multiply 2 times 1, that gives you 2 over x squared. Can you follow? Another thing also, since it's in the parentheses, inside the parentheses, so the whole thing in here will become in the denominator, or will be put in the denominator by getting its reciprocal. So we have it 2x, 1 over 2x, closed quantity squared. See, the exponent becomes positive by applying the zero exponent rule. So applying the another rule of exponent, when we distribute the exponent outside, that gives us 2 squared and x squared. So 2 squared is 4, that gives us 1 over 4x squared. Okay, so I hope you can follow. This is just a recap about what we had just discussed last time. Okay, For division properties, there is only one quotient rule that I've mentioned a while ago. And according to the rule, this property is used when dividing two or more exponential expressions with the same base. What will we do? We copy the base and subtract the exponent. Another illustration that we can have, x to the power of 5 can be written as 5x. As you can see on the screen, x cubed in the denominator can be written in 3x. So we cancel. We will not use the word eliminate. We use cancel because the answer is equal to 1 when we cancel. Why, sir? Cancel means when you divide by itself. 2 divided by 2 is 1. So 2 can be canceled, which is equal to 1. So x divided by x is 1. So we cancel the red lines shows that we cancel the x. 3x that will be canceled in this solution. So what will be left are 2x, and then there will be 1 left in the denominator. So x times x becomes x squared, applying the product rule. So that's how we do the quotient of powers. I hope you will be able to relate this topic in our previous topics about the quotient rule. So that's power of a quotient. As you can see, x squared y cubed. So what will we do in here? We distribute the exponent outside to the exponent inside of our fraction. So x squared times 4, look at, and y cubed times 4. So 2 times 4 is x to the power of 8. 3 times 4 is 12, so y to the power of 12. So this is how we use the power of a quotient. I did not discuss this one last time, so I want you to remember this one too. So you want hard examples? Let's see if you can sustain. I will not use the word hard. It's challenging. Challenging example. Oh, that's something like simplifying. So how will you do that? Oh, how many laws of exponents that you can apply in there? Let's see. Okay, so we distribute the power of 3, the cube in here, to both numerator and denominator. We had a separate distribution of the cube. Next, we distribute the cube to each expressions in numerator and in your denominator. So 3, that's why it is 2 cubed. So 3, there is 1 for 2x. That's why it's x cubed in the numerator. And 3 times negative 2, that becomes negative 6 in the numerator. And also do the same thing in the denominator, the cube. Distribute to 3, that gives you 3 cubed. And also to x. So 3 times 3 is 9. And then 3 times negative 4 is negative 12. Okay? Can you still follow? Yes, you can still. Then you can divide it. 2 cubed means, for a while, it's hanging. 2 cubed means 8. 2 times 2 times 2. X cubed, then y to the power of negative 6. Get its reciprocal. To get its reciprocal, it will become in the denominator. And also in the denominator, we have 3 cubed, we have 27, x to the power of 9. Since y has negative 12 in its exponent, then we can get its reciprocal by putting it in the numerator, the reverse, the inverse, or the reciprocal. So that's how we do it. Applying the negative exponent rule, remember? So you can have it 8x cubed y to the power of 12 over 27x to the power of 9 y to the power of 6. So you can, you can subtract 9, your x, 9 minus 3, and also 12 minus 6. So that gives you, again, remember the one that I said, you subtract the variable, the exponent based on the highest degree. So for our x, since 9 is greater than 3, so we are going to subtract the exponents or the exponents of x in the denominator. So 9 minus 3, that's why we have it x to the power of 6. In this case, for our y, since 12 is greater than 6, so we will do the subtraction of exponents, applying the quotient rule in the numerator. That's why we have it y to the power of 6. So, is that our final answer? Okay, let's see. Sorry, it's hanging. My PowerPoint is hanging. So that's the final answer. 8y to the power of 6. Sorry, 8y to the power of 6 over 27x to the power of 6. So that's how you do the simplifying or applying the laws of exponents in simplifying algebraic expressions. So there are cases that you will use the all the laws of exponents in simplifying algebraic expressions. That's the most challenging thing to do here in this topic. So I hope you have learned something so far, and see you in our next video, maybe tomorrow. So please continue to subscribe and watch the video. Do not skip the video because you will not learn something. Just start it and then listen from the start until the end of the video. So I want everybody to really learn things in here. So do not forget to subscribe my channel. If you like it, share it to your friends, especially those who are struggling in math. And aside from that, you can click the yellow bell button. And then after that, you can also request in the comment section. You can post your comment there if you have some concerns. And of course, thank you so much to all subscribers who keep on watching the videos that I am posting in my channel. So have a great day. Have a nice day. So another learnings that we have learned this evening at this video discussion. So thank you. Math is fun. Always remember, math is easy, not difficult. Thank you for listening.